Hello everyone, my name is Paranjay Sharma. I am a student at IIPS DAVV pursuing MCA currently in my 5th semester. This video is regarding my assignment for data science. So this is the second video for the playlist for my first internal test of introduction to data science. So let's begin with the part B of the first internal test, which is similarity and dissimilarity in feedback. So first, the fifth question, we were on the fifth question. So the fifth question is basically asking for us to outline and compute the dissimilarity between student feedback profiles by these four methods. So first, we will have the nominal attributes. It's like, for example, we have department or elective chosen. So in this, what we are doing, it's a simple matching approach. So number of the formula, the distance is calculated at I comma j, which is the data point 1 and data point 2. So number of mismatches divided by total number of nominal attributes. So for example, if there are two students who belong to the same category, the similarity equal to 1, the dissimilarity equal to 0. Otherwise, the similarity equal to 0 and dissimilarity equal to 1. Similarly, moving on to the next point, which is asymmetric binary attributes. So for example, it's like a yes or no question: did you attend the workshop or not? So in this we use one uh, where it is more important than 0. For example, attending a workshop, 1 equal to attended, 0 equal to not attended. We use the Jacquard dissimilarity over here. So the distance I comma j is calculated as q plus r divided by p plus q plus r. So that is p equal to both are 1, q if I, that is the first data point, is 1 and the second is 0, and vice versa for r. If there are 0 matches, those are ignored because they don't convey any information. Then moving on to the next, which is the numeric attributes, example CGP, attendance percentages. So in this we use Euclidean distances, Manhattan distance, which is optional, not optional, we can use Manhattan as well. So it's for Euclidean, the formula is square root of x I minus xj, that is the the data point value of first data point and the value of the second data point, the difference between those, the whole square of that, and the summation for all those points, that is x1 minus x2 plus y1 minus y2 plus z1 minus z2, all whole square and summation, and then we take the square root. So that's how we find the Euclidean distance. For a Manhattan distance, the formula is summation of absolute. It's the same as Euclidean distance, but the absolute difference. The only difference between them is absolute difference without any square root and square. Similarly, we do summation also in Manhattan as well. Then moving on to the next part, before moving on to the next part, I would also like to tell you about more about numeric attributes, which is they are using min-max normalization, z-score normalization. They prevent large ranges from dominating, that is any outliers are prevented over here itself. Then we have term frequency. These are basically vectors, so vectors of word frequencies. We use over here Euclidean distance on TF vectors. It's less common, but we use cosine dissimilarity. So it's calculated as 1 minus the similarity, and similarity is calculated by a dot b divided by a into b, the mod of that. So that's how we find the cosine dissimilarity. This is a basic conclusion for that. Moving on to the next question. Okay, it's repeated over here. For some Now for the summary part, nominal. In nominal, we just count mismatches, the simple matching. Asymmetric binary, we use Jacquard dissimilarity. Point to be noted is that we ignore 0-0 matches. Then we have numeric attributes, in which we find Euclidean or Manhattan distance after normalization, and in text TF vectors we have cosine dissimilarity. Moving on to the next question, we are given two tuples A and B. We have to find Euclidean, Manhattan, Minkowski and supremum distance. So for the Euclidean distance, we already know the formula. We just put it 22 minus 20 whole square, 1 minus 0 whole square. Similarly for all the data points, and we take a summation of all that, that is plus plus plus, and then we take a square root. The answer would be 6.7. In the Manhattan distance, as we already know, we take the absolute difference and then take the summation of the absolute differences. In the Minkowski distance, in which we have given p, we are given p equal to 3. So what we do is we do the whole power 1 by p, that is over here 1 by 3. It's x1 minus y1, that is basically 22 minus 20 whole cube. Okay. Similarly for each and every data point, summation of that. So the answer will be 6.14 for that, and Manhattan 11 would be the answer. For supremum distance, we take the max from xi minus yi. So that is 22 minus 20 will be 2, 1 minus 0 will be 1, 42 minus 36 will be 6, and 10 minus 8 would be 2. We put all these values, we take the maximum, and that is our supremum distance. So moving on to the next question, which is question number 7. In this we are given a statement in and that we have to analyze. Okay, moving on to the next question, which is question number 7. Here we are asked about median approximation methods for large feedback data sets. So these are a few methods which we can use. So first is random sampling. We take a small random sample of the full data